My phone's speech-to-text translation has been giving me a lot of trouble, so I'm going to do it this way and save myself a lot of hassle. There's nothing wrong with quantum theory. I know Eric Dollard rails against it. Its advantage is that you can make yourself look very peculiar and unique by comparison to electrical engineering so that you can get government funding to do what you normally couldn't do under the auspices of electrical engineering, because electrical engineering is very practical and very readily available, while quantum theory, only a few priests of the physics profession can access that knowledge. It's so arcane. And it doesn't mean it's wrong. It just means it's not practical, it's costly, and it requires a lot of prestige and finesse to accomplish what? Just get a lot of money to study something? There are a lot of government grants for studies that are not practical and are even sarcastically lambasted in the various movies that make an allegation inserted into the script concerning some arcane government grant somebody manages to live off of, performing a study on something that's not going to benefit anybody one way or another, regardless of the outcome of the study. It's just going to give somebody a nice armchair philosophical or intellectual or scientific, armchair scientific endeavor. One of the problems is that free energy has a specific purpose. And the way I look at it and the way I promote it in my books that I sold on Amazon and PayHip and I give away now for free, I even did a pitch deck on this concept, is that we have limited natural resources, because if you wanted to go 100% natural, wind, solar, tidal waves, wave action, and not tidal waves, but tidal energy, we literally would crowd ourselves out of existence because we'd have to devote so much space, and it's not even practical, that there wouldn't be room for us. It's not even practical. I give the example in my book in what kind of car would you want to take your date out for some midnight romancing, given the fact that if you wanted a car that was unlimited in its range, the whole point of a solar panel that you put on the roof of your home, if you have a home to put one on, is to transfer that energy to a concentrated energy storage device, a battery pack, which you put in your car, which gives you limited range, and that's the only way we are told we can do this. Otherwise, you have to go to an outlet somewhere in the public sector to recharge your car. And now, if you want it convenient, you have to risk shortening the lifespan of your batteries if you supercharge your battery pack instead of just doing it the trickle way or the normal way, L1 or L2 or L3, if you know what I'm talking about electrical charging stations and their various degrees of rapidity. The faster we charge the battery, the shorter is its lifespan over time. Yet, we are taught that recycling is the way to go of the future because we have limited resources. We pay people to recycle their bottles, their cans, their paper goods, even their organic waste to make compost piles out of in fresh new soil. Yet we never tell people to recycle their electrons or their energy, their electrical energy, or any kind of energy. But let's just keep to electrical energy. Even though it's not impossible, even though it would be cost effective, because now we get to scale down the size of that solar panel on the size of the roof of our home, and now we don't have to live in a home to have a large enough roof area to put a solar panel on to recharge our car and not have to go to the grid to recharge our car if we go to work every day and we don't do any excessive driving. We just drive to work. Our driving is pretty much regulated, and so we can accommodate it with a roof and a home, a single-family dwelling, home-size roof area to put on a solar panel. Because we're not wealthy, we don't have a huge backyard to have a huge solar panel, not array. Not that we couldn't go that way if we lived out in the country. Then we could go that way, but still, you can't put that on top of a car. It wouldn't fit. And even if you shrunk down the size of the car, the weight, the mass of the car, how could you take any groceries home or luggage to go to the airport, or you just stick yourself in this bicycle-sized car that's completely covered with solar panels on the top side. Now you've got a car that nobody wants to buy, even though it's detached from the grid and it has unlimited range. So the whole point of making use of electrical reactance and so-called free energy, or freely available reactive power, is to simply get more use out of less energy by recycling it, and thus not have to have a battery pack at all, maybe. Just the auxiliary battery under the hood that, runs the normal equipment, just like it normally does in any internal combustion engine-oriented car, and shrink down the size, the requirement for the size of a solar panel to the size of a solar panel on a, a pocket calculator that recharges its battery all the time. And stick that on the car and recycle the energy input such that now you have unlimited range for your car, and you can make the car the size of a battleship if you prefer. Your power supply system will have to be enlarged because now you have to increase your capacitance and inductance, and you might have to tinker with the frequency to be able to put out power per unit time sufficient to match the needs of a battleship versus the 100,000 watts requirement of an EV. But one way or another, you are able to match the needs of that vessel using a solar panel no bigger than the tip of your finger, I mean, it's literally ridiculous what we teach ourselves to put up with. Literally. Power supplies can literally be built into every appliance to power that appliance and no longer need to plug it into an electrical outlet. It's literally that straightforward. Now that's practical, and that doesn't require quantum mechanics to understand. So, let's posit the possible thought, that quantum mechanics and electrical reactance are not one and the same, as I had already stated. Yet, they share so much in common they look like parallel universes. Kissing cousin parallel universes. They are that closely similar because in both instances, space is no longer an exclusive requirement for either one. Not that space can't modify it further, but you literally could depend on time alone, the manipulation of time, to get the job done and not have to turn to the modification of spatial considerations, geometrically, size, mass, whatnot. Because, an inductor, if you want more inductance, you got to increase the size of the coil. Same thing with a capacitor. But if all you have to do is change frequency and phase relation among the components of a wave or among various waves in order to modify electrical reactance, that saves a lot of trouble. Now, when you quoted Tesla at 20,000 cycles per second, you were presuming the requirement to depend on our natural environment for your source of energy. Me, I don't look at it that way. because I see energy coming from energy. I don't see it coming from anything else. In other words, there was no Big Bang. There was no Genesis like in the Bible, before the creation there was nothing, there was the void. That's bogus. Creation and the creator that created creation have always coexisted. Never did one come before the other. There is no chicken coming before the egg or the egg before the chicken. They always coexisted, and they have to coexist in order to have any relevance in their own integrity. In other words, the creator has no relevance unless the creator has a creation. The creation has no relevance unless the creation has a creator that spawns it. It's a eternal, immortal, bidirectional relationship, interdependent relationship, codependent relationship between the creator and his creation, or its creation if you prefer. You can't have one without the other. And you can't have both without the gap between the two, and the gap between the two is where electricity exists. That's why it's so hard to understand it, because we keep looking at reality the wrong way over the long stretch of time, as well as spatially consideration. How do they interact? So they both have to coexist, and there's a gap between them, and that gap creates a relationship which creates room for the electricity to blossom and come into being. Because if there was no gap, there would be no room for the electricity. Conceptually speaking, a gap. Conceptually speaking, a gap. So it's a three-part relationship between the creator, his creation, and the electrical relationship between them. Now, if you're the creator and you want some more energy to happen somewhere, don't you think you just will it into being? Don't you think we are, well, see, now this is the problem. In Genesis, we say it's sinful to us presume that we could ever be like the Almighty. Yet that's our purpose in life, is to become our own self-almighty, capable of manifesting our own creation. We already do. We think thoughts. That's already manifesting a creation, but they're imperfect. They slide away into ever-shrinking oblivion and discordancy over time, never quite reaching zero existence or infinite chaos, but keep sliding in that direction because we're not perfect. We're not gods. We're not almighty. So our creations, just our thoughts alone, just considering our thoughts alone that we create, veer towards greater chaos and greater faintness of existence. Yet if we were perfect, if we were almighty, our creation would be perfect like ourselves. So we are almighty supreme beings in the making, and our creation likewise. Yet our creation always coexists with ourselves, because all creatures, no matter what they are, even a crystal, a so-called inanimate crystalline structure, or even a blob of water, which is semi-crystalline, is busy creating action and reaction. We call it chemistry or electricity or whatever. And that action and reaction is a creation of a sort. So all beings, all objects are beings, and all beings have creations associated with them, and they all have an electrical relationship. In other words, when I study electrical reactance with regard to the synthesis, as Eric Dollard calls it, as opposed to the decomposition of electricity, I'm looking at the augmentation of pre-existing electrical energy that's already there, may not be big enough to measure, but it's there, and you can augment it or you can shrink it. It's like expansion and contraction. So we're not creating energy, we're not destroying energy, but we are expanding it or contracting it within a framework of time, using electrical reactance to do so. Now, if we take that perspective and apply it to the analysis of the electrical analysis of the chemistry of an explosion of dynamite, and then once we've finished our analysis, remove the chemistry of the dynamite, and then replace it with an electrical circuit. Could be a gaseous electrical circuit, but just something, or a mixture of gaseous matter and solid matter, or whatever it takes to efficiently duplicate the electrical behavior of that dynamite becoming exploded. We now have the electrical equivalent, and wouldn't you think it's kind of similarly powerful? Yeah, I would think so. I mean, I literally looked at electrical explosions in various simulations that are so extreme, they have all the earmarks of TNT, or any kind of chemical explosion or atomic explosion. It really doesn't matter where we go with this. That's why I say quantum mechanics probably is the equivalent study of electrical reactance taken to the nth degree. The physicists have gone so detailed and so arcane in all of the finesse of electrical reactance that it may lose its sense of commonplace understanding, which is borderline impractical for the common person at any rate, not for the nuclear physicist who wants to get government grant funding. But for the rest of us, it's like out of our box of thinking and being and acting. Yet it doesn't mean it's not there. Eric Dollard might be going too far in saying that it doesn't exist. It does exist, but it's allowed to go to such extreme because they went and re-qualified it by giving it different names at the start, so that they could then go into the details further. That's what it looks like to me. Yet, again, going back to practicality, if we can shrink down a solar panel, if we can shrink down a radio broadcast aerial that a TV station or a AM radio station has to make use of, if we can shrink that down, we've increased efficiency. And we've increased the likelihood of portability. And now we're getting into the same kind of ideology in which the Dick Tracy watch has become our silly phone, as Eric Dollard likes to call it. Now we take the battleship cruiser and we shrink it down to the size of our Dick Tracy watch scale of magnitude. In other words, we've managed to miniaturize power to the nth degree. And then Eric Dollard's complaint gains relevance that we don't deserve this kind of technology. So maybe it's better that he not admit that he knows more than he admits to. He's already told me in a letter several years ago that there are certain network analogs that he will never share with anyone. There are some that he would like to bring out at a later date, and this was half a dozen years ago. And he has done so. He has given presentations in which he has gone a little bit more in depth into what he knows about analogs to various versions of a transmission line network. But he admitted to me some he will never share with anyone. Why would you think he would say something like that? Because they are extremely powerful and dangerous in all likelihood, either in the wrong hands who don't know how to manage it, or in the wrong hands who don't know how to what's it good for except to create danger, Will Robinson, danger. I'm sorry, that's a allusion to an old TV program, Lost in Outer Space, or Lost in Space, I think it's called. Yeah, danger, Will Robinson, danger. Robbie the robot, carried over from Forbidden Planet, given a TV series of his own to play and to act in. So that's my take on electrical reactance versus quantum theory, quantum mechanics. There's some things I can only agree with Eric Dollard, and some things which I can understand why he has to disagree with physicists. There's a political reason for that, because we've politicized electrical engineering, or one aspect of it, electrical reactance, to the extent that we have to make it arcane and archaic and unreachable by the common sense person to figure out and understand and appreciate. Because when it comes right down to it, what can politics sell to the consumer will dictate what the consumer will support, what policy, government policy, the consumer will support en masse as a collective entity. And when you can manipulate public opinion to support a specific agenda or set of agendas, you've got a good thing going. A very good thing going. Because now the power of an A-bomb, literally, some people like to think that the Tunguska event in Siberia was a Tesla experiment that did not go awry. It was actually successful. And if true, shows that electrical engineering can create as much powerful destruction as a fission or fusion bomb can do, without any of the radioactive fallout, but a massive amount of destruction. Now, where did all the radioactive fallout go to? Okay, so maybe that's the difference between quantum mechanics and electrical reactance. So now I have to admit that there is no, they are parallel, but they're not equivalent. Yet their parallelism is very significant because it has to make you wonder, how did the A-bomb go off in the first place to create the same level of energy release? If we take, that statement that I was corrected by somebody did not come from Einstein, he simply made it more popular and famous, but actually comes from Oliver Heaviside, the E equals mc squared equation. If that is correct, then what we have is a parallelism so closely similar that they are equivalent. Yet why do we not get radioactive fallout with an electrical reactance event, yet we do with a fission or fusion nuclear event? That's something I don't, it's worthwhile that I ask the question to show that I still don't know something, right? I'm not a know-it-all here, but at the very least, it makes you wonder why we go to so much trouble to create nuclear reactors, or have done so in the past, when we could have done what Tesla did instead and never got the chance to commercialize in all these years since Tesla lost his commercial livelihood. Namely, the last 40 years of his life was commercially dead, from 1903 to 1943, more, give or take a year or whatever. It's actually more like 42 years, because I think it's 1901. When he left Colorado Springs, Colorado, was pretty much the end of his becoming commercially successful at anything. Well, in fact, just going to Colorado Springs, so what was that, 1899 was already, he was turning his back on being commercially practical, which is 44 years. So almost half a century, he was commercially impractical in the consideration of what experiments he pursued. Yet, he pursued them anyway. Because he had a knack, he had a momentum, and why waste a life if you don't put it to some use, even though it may not benefit anyone, except your own amusement, which is pretty much what he did, in a very frustrating way, I would imagine. I mean, some of these stories I read, you have to wonder how much frustration is going on. John Jacob Astor, I forget what number, was it Junior or the third, who went down with the Titanic. The story claims that he was going to fund Tesla, and that was a nice way to cover up the murder of John Jacob Astor by murdering a bunch of other people along with him, so that there would never be an investigation or allegations made as to who is trying to destroy Tesla. And then President, was it Garfield, was doing a train junket of lecture tour, as such as presidents used to do in that day, time and day, frame of time, once a week. And his next whistle stop was Buffalo, New York, because, that's where the Niagara Falls power plant is located. So he was going to give one in honor of Tesla and give his support and political backing to Tesla's endeavors. And he goes and gets assassinated. I forget which president that was. I'm assuming it's Garfield, but it might have been somebody else. These kind of stories make me wonder. Sure, they're conspiracy theorist-oriented stories, but it makes you kind of wonder, how else could somebody be so thoroughly commercially dead for 44 years if it was not a conspiracy to suppress any further commercialization of Nikola Tesla's ideas? And then we're left wondering, what the heck was he doing? Because we have no idea. Most of us, all we can do is speculate. But just looking at the simulator as my teacher, and anybody else, including Eric Dollard, is simply filling in for the simulator's inability to talk to me and describe to me what it's doing and the significance of what it's doing. I then still have to figure out what is the significance of what it's doing. But when I look at it, it simply does what it does. And depending on how expensive the simulator is, will determine how realistic it is and how difficult it is to create free energy. But that doesn't I have yet to see it become impossible, unless policy is written into the software code, irrespective of the policy having nothing to do with electrical engineering, just policy decisions that cause the software not to behave true to reality. But the expensive simulators can't afford to do that, because electrical engineers make their livelihood using simulators before they go to the bench to save themselves time and materials and expense in their pursuit of their coming up with a new circuit design, be it digital or analog or a mixture of the two. So simulators are valuable, and that's why I'm still stuck in this stage of developing my skillfulness in this area, because I understand that what's needed is not theory. What's needed is a reflexive skill. In other words, when I go to the simulator, to a limited degree, I don't have to think. I just play around like Edison style. I play around with parameters and arrangements of components. And I've developed a skillfulness to come up with something that produces free energy. Now, people will criticize my work as saying I'm taking advantage of the simulator. But when you get to the high-priced ones, you cannot take advantage of them. They will put up a red flag and stop you dead in your tracks and say, sorry, you don't get to get away with this. And if you want to go forward, you got to make some changes. So I have to conform to the rigor that the simulator imposes upon me, especially when it's an expensive one. And I don't get away with anything that's obtuse or arcane or fanciful or imaginary. That's why I took issue with your use of the word imaginary. Eric Dollard likes to go there because, again, he is taking a political stance of his policy to discourage us from going in the direction of free energy. So he has a reason for using the word imaginary when applied to the synthesis of electricity, because he doesn't want us to go there. And then I look at it and I see frequency as the only thing I see besides capacitance and inductance, which are both manifestations of physicality, but frequency is not. I mean, the only thing frequency is in regards to ephemeralness is potential energy, not kinetic. The potential resource of the spectrum of the electromagnetic wave spectrum is potential energy, not kinetic, but does have an indirect impact upon kinetic energy and thus is worth looking into. Its manipulation, the manipulation of frequency. Because the advantage of frequency is that we look at losses, thermodynamic losses, per unit time, and then we look at frequency of reactance, and if we can speed up the trend of a reactance to blow up in our face, then we can offset the losses incurred thermodynamically such that now the losses are less than the gain, the electrical reactant gain. The thermodynamic loss is less than the electrical reactant gain per unit time. And so now we can accumulate energy instead of lose energy. So there is a slant that the consumer is forced to look at. Oh, you can't have more energy out than in, which is only true under limited circumstances, having to do with a few factors, none of which are elaborated at all to the consumer. So the consumer is left with the ideology, I have to go out and buy a battery, and then I have to go and recharge it in order to get my EV to run. Otherwise, I can forget about it. I might as well be Flintstone style, dig a hole in the floor of my car and use my feet, because they literally sell us a false bill of sale as to the reality of the situation. But I see it in terms of time, as well as capacitance and inductance. That's all I have to, and that's what Eric Dollard says. He just doesn't use the same terminology, but when you think about, magnetism, that sounds like inductance, and dielectricity, that sounds like capacitance, so I don't know. And time, there you go, the same thing. So to me, it sounds like he's talking about electrical reactance, which is nothing new. It's been around for more than a century, but who bothers to think about it? And I could give you another parallel. There are so many parallelisms, historical parallelisms. Oliver Heaviside and the Ferrante effect. The Ferrante effect said throw massive voltage at the transatlantic telegraph cable problem, and we'll somehow get through this problem of sending a signal across the Atlantic. And Oliver Heaviside, who was not an electrical engineer, he was a mathematician, went and mathematically modeled very accurately the problem, and then came up with a solution. Because he, like Steinmetz also, if you mathematically model something correctly, you can usually come up with a solution. It makes it easier. So he decided to wrap iron ribbon around the insulated copper core of that telegraph cable, and lo and behold, he reduced the loss of electromagnetic energy as the signal crossed the Atlantic, so that the magnetic component of the signal, the magnetic field, could keep pace with the electric field and not diminish, and you'd just be left with the electric field, and the magnetic field is taking forever to catch up. Well, I look at it the same way when I look at the problem of electrical reactance, because we've got the battery pack throwing massive voltage at the electric motor in an EV, in an electric car, and that suppresses electrical reactance. I found under simulation there's a window of opportunity that spans somewhere between 1 microvolt and about 10 volts. And somewhere within that window parameter, electrical reactance can flourish to become your major source of electrical energy and turn your voltage source into a mere stimulus that has to be kept up on a constant basis sometimes, or not, depending on the situation, depending on the circuit. But be that as it may, your stimulus, whether it's an instantaneous snap switch or whether it's a constant input, the stimulus is a millionth of a volt. because any more is like a fat lady sitting on your chest and you can't breathe. When we run a circuit in a normal electric car, all we are doing is allowing for exhalation of the battery pack's voltage and not allowing for inhalation to occur, namely the expansion of a chest of a person taking in more air and increasing the oxygen of the blood, oxygenating the blood thereby. We don't allow that because we throw so much massive voltage from the battery pack at the circuitry of the EV that all we can do is drain the battery pack. Just like a fat lady sitting on your chest, all you can do is exhale, and then once you've exhaled, now you die. Because if she doesn't get off of you, or a fat guy, let's be fair about this. A fat person sitting on your chest, or just a ton of bricks. We put a ton of bricks on your chest, and all you can do is exhale. But if we take those bricks off the chest and we allow you to inhale and exhale freely, now you can alternate between cycles of expansion and contraction of the energy quota, the magnitude of energy, electrical energy within the circuit, and keep it going. Keep it sustained per unit time to match the per unit time load requirement, because that's what's needed. Per unit time, you got to match the load. And so now you have to look at the circuit in terms of its two phases. So now, we think of diurnal phases of electricity as if the only diurnal phase is an alternating current perspective. But that's a bait and switch there to obfuscate the relevance of looking at expansion versus contraction of electrical energy, electrical reactance energy, to keep the electrical magnitude within the circuit going long enough so that we end up having a perpetual motion device that can sustain itself. Even though we may still have to input and stimulus, but the stimulus is so small that it's orders of magnitude smaller than the output in the extreme. Just like the EV Gray motor was found by the Bing Crosby Foundation to have something slightly less than a 300 to 1 output to input ratio. It was something like 290 to 1. It was so humongous. They literally did not know what to do with the excess energy at first. Richard Hackenberger, for quite some time. It took him a while to figure out what to do with it. They eventually knew. They had to force compressed air through the device and change the parameters of how they constructed so that they could ionize that compressed air and blow it out of the machine to take the electrostatic field it was creating away from the device by converting that electrostatic field into ionized air molecules that could then ground themselves out to nearby objects. Otherwise, they were creating an FCC hazard, or else they wouldn't have had an FCC raid to shut them down. And the FCC are pretty thorough. They'll take your desk chair. They'll take everything. They don't want you messing with your electrical environment just because you want to create free energy. So there are hazards to being successful in this area, but it does kind of beg the question, why do we have a government policy, or why do we have a demographic policy that's pervasive, a pandemic policy that steers us clear of serious electrical engineering research? And this, again, I have to agree with Eric Dollard that serious electrical engineering research has ended about a century ago. We haven't done it since, because we do all of this other stuff instead. We've gotten into biochemistry and digital electronics, but we've killed the analog electrical engineer, the relevance, the pragmatism of that sort of pursuit. And so on a shoestring budget, or on a zero budget, at exclusively an expense of my time, I pursue this with no formal training whatsoever, because no one would let me if I took formal training. I know. I tried to take electrical 101 beginners class in college twice, and I didn't like any of its approach. I had a knack for it. I could have been the teacher's pet the first time I tried because I knew the answer to his question, what's the difference between induction and conduction? Or, no, that was my answer. That was, what's the difference between, what was it, current and voltage? Yeah, I think that was it. One is action at a distance, and the other is um, action that cannot be done at a distance, but you have to go and touch it. You have to, create a conductive path. So I already intuitively could simplify the problem, and could show that I had potential in studying the topic, but I didn't want to because I hated the emphasis on math. So this way I get the simulator to do all the math for me, the number crunching, and I just deal with the big picture. But I let the simulator tell me what's possible, and then I have to go to theory to figure out why I succeeded where other people have failed. And Eric Dollard has had the relevance greater than any other person. Other people have come close. Jim Murray has come close. Paul Babcock has come close. Aaron Murakami has come close. Evie Gray, all these people have come close. But I can't cite Tesla because he's, so far along ago that nobody understands. I don't understand him. The relevance of citing him as a source is pretty kind of ridiculous because he's not a teacher. He never left anything behind. He didn't want to teach anyone. All he had was secrets that he kept very close to himself. So it's hard to use him as a resource to cite as a reference. So I have to get all these people who stand in between him and I. And Eric Dollard comes out to be the person who is the most relevant because he has been the most articulate. Yeah, he's the most articulate of anyone. But there are people who do come close to that relevancy of articulation, but he's the best of them all. But he doesn't, like I said before, he doesn't tell the whole story for certain policy decisions of his own. He doesn't want to encourage us to go in the direction that some of us would love to go in. And 20 years ago, his gripe would have been relevant because if somebody came out successfully 20 years ago and commercialized it, it would have improved a lot of people's lives. But it's a little too late now. And I don't want to spend too much time on this part of this discussion, but it is too late to help anyone other than oneself. And it really has become the attitude of a lot of people, or I shouldn't say a lot of people. It has become the attitude of a few powerful people that every man for himself is the only way to live these days. And that's probably the only reason why we have the troubles that we currently do have, is because they're being made for all of us on our behalf by just a few people. And not by any error, but by design. So, I have a kind of conspiratorial way of looking at things, but then I'm an activist. And activists usually are conspiratorial in their outlook. They usually point the finger at someone to blame, or else they would not be protesting, would they? They would think, well, it's just a happenstance, or an act of God, or an act of nature, or something, But no, if we can point a finger to some greedy individual who's power hungry or money hungry or both, or wants to play God with people's lives, then we like to be conspiratorial in our outlook. And then go out and protest, and let everybody know what we think. So that pretty much is my perspective. I am no electrical engineer by any means, but I am an activist in the sense that I am upset over our ignorance. Upset over my ignorance, that I've had to go spend my waking days and nights training myself using a robot, artificial intelligence, a simulator to be my teacher, to get past all of the human policy decisions to keep me ignorant and somehow teach myself anyway. Discovering on my own that I already have a knack for this. I have an inborn tendency to understand the subject. Had I a teacher that I could look up to. And I guess I'm too shy or too pessimistic to make Eric Dollard my teacher, but at least he's a role model. He can serve that much capacity for me. It's probably shameful and embarrassing for me to admit it, that I wouldn't want to. Well, why don't you just go to Eric Dollard and have him answer all your questions? Because whenever I wrote him letters, he backed away in a very polite manner. He says, "Oh, that's excellent what you're doing, but I'm not going to comment." So he always left it to me to figure things out on my own. So, okay, fine, whatever. And that's what I've had to do. But he has published a lot of written material, and some of it is very telling. Or what he's spoken to other people that has been publicly recorded and shared, or publicly shared. Like that video of him in the interview, Tesla 2.0, in which the guy actually asks him, and he tells him, this is what electricity is. It's apple pie. You put the ingredients together, and now you've got apple pie. Take them apart, and you don't have apple pie anymore. Electricity vanishes into thin air. So I have to agree with that, and it makes it look, again, the parallelism, just like atomic physics. You take apart the atom, which by definition you're not supposed to be able to do. Democritus, the atom is the indivisible unit of matter. But when you take it apart into its subatomic particles, and you don't have atomic matter anymore. Which makes you wonder, okay, well, if you can't take volts and amps apart from electricity and still have watts, then in a sense, a watt is an atom. It's a non-divisible unit of energy. Although I know we're supposed to say joules, but it gets to be too much for me. My simpleton brain, my grade school level of intelligence on this subject. But be that as it may, whether it's divisible or indivisible, I know that you can stretch electricity to the point of nearly breakdown, so that the amps and the volts are still connected. It's just that 180 degrees phase difference between them. They're practically separated, but they're not. They're still together. So Ohm's law still applies, yet it does not apply. The tenacity of Ohm's law still applies. But now Ohm's law gets turned on its head, and now it's Mohs law. Now it's conductivity rather than resistance. Now it's Siemens rather than Ohms, unit of measurements. So the tenacity of the multiplicative relationship between amps and volts is still there, but the behavior is something entirely oppositional, entirely complementarily oppositional. And now, instead of positive resistance, we get negative resistance. And negative resistance is a very interesting phenomenon. That's why one of the modifications I made to Paul Falstad, my instance of Paul Falstad simulator that I host on my website, was to create the allowance within the software code to have a negative value for a resistor. And although I wouldn't know how to build that, right? But when I look at the parameters of a neon bulb spark gap in microcap simulator, they literally have one parameter in there that says negative resistance of this component once of the voltage breaks down to its new lower voltage level or resistance level is negative 1 ohm of resistance. They arbitrarily chose negative 1. It's like, why? Well, because maybe it doesn't matter. I don't know. But they do put it in there. And we know from, Wikipedia articles says, what gas discharge tubes do, they create negative resistance. So it's like, okay, something's going on here, and it's not your normal stuff. But if you have the freedom to have a negative resistor in a circuit that's not a spark gap or a neon bulb, it's just a resistor with negative resistance instead of positive resistance, it makes it so easy to conceptualize what free energy should amount to in an ideal situation. It's the equivalent to having a negative resistor adjacent to a capacitor. Yeah, I found that out. You have to put it in line with a capacitor. So I did a loop. I had a battery source, right, a battery and a negative resistor and a capacitor. And I think that's the circuit. And for some reason, the presence of the capacitor turns that negative resistor into an energy source greater than the battery. Greater than the battery. But you still need the battery. You need the stimulus. But there's no frequency there. So under such an ideal situation, you don't need frequency anymore in the sense that we're only considering one half of a cycle, of an AC cycle. And now we've completed it because the negative current is the other side of the alternating current working concurrently with the positive current coming out of the battery. But it overwhelms the battery's current. Yet we have both halves of one AC cycle. So if the capacitor represents anything, it probably represents in a very stylistically simplistic manner what an alternating current system amounts to. It amounts to a capacitor, basically. I know we say an inductor creates back EMF, but the capacitor really creates, because it blocks DC. So a capacitor can't function in any way other than an AC situation when it's in line. So it's very interesting that a negative resistor, all it needs to really manifest its overunity is a capacitor in line with itself. Otherwise, the property of the benefit of a negative resistor does not manifest, does not materialize. If all you have is a negative resistor and a battery, nothing interesting happens. But put a capacitor in there in the mix with a 3-part circular arrangement of components, and something really bizarre happens. So it shows how little we know about the situation. Just that simple example alone. Now, if I can think of the shortcut URL, if I can remember what it used to be is.gd / NEG RESIS, but I think it stopped working and I had to make some adjustments, so I may have changed it. But it's on my website, vinyasi.info / N as in Nancy, E as in Edward, the first 2 letters of negative resistance phrase. And it's under new components. The 2 new components being a transformer and a resistor. And I give 4 types of negative resistance, namely, is it positive, is it negative, is it reciprocal, or is it non-reciprocal? And the one that seems to look the most interesting is the negative resistor, not the reciprocal, oddly enough. Assuming I thought turning Ohm's law on its head and making the reciprocal of Ohm's law would mean that that's the more purist way of looking at the situation, but it's not. For some strange reason, it's negating the positive sign of a resistive component's parameter to make it a negative ohm of resistance rather than a positive ohm of resistance. That's when the resistor becomes interesting. Anyway, so I think I've said everything I need to say. Okay.